Okay, so we just finished up with the first problem on the X review, so let's work on the second problem here. We're going to follow the same type of format, and if we see anything that's different from this one, we'll point out the differences and explain why we're doing those. But you know, usually these graphs kind of go on a case-by-case basis. There's a lot of like little tiny small rules that go along with each of the different parts that we're looking for. We just need to make sure that we're solid on those rules when we're graphing out. But remember that you can always fall back on your graphing calculator. Just kind of make sure that you're on the right track with each part of it. But you do need to show all of this stuff for credit. So make sure that you know how to factor, know when to solve for zero, you know, like that kind of stuff. And you know, factoring is the big part of it. If you make sure that you factor, that's like a good chunk of your partial credit that you're going to get. Anyways, so we're going to go ahead and factor this and graph it out also on our calculator. So factoring it first, the top part, we can factor out a 9 from the top, so we get x squared minus 1. And the bottom part, that's a sum of squares, so we're actually not going to be able to factor that at all. Even though it looks like we could, we cannot. The only way that we can factor this type of expression is if it's a difference of squares, like what we have up here in the numerator. That's nice. That turns into x plus 1, x minus 1. But notice that even that one little change from a plus 1 to a minus 1, we can't factor that bottom part at all, so that's still x squared plus 1. Okay, so let's graph it out as well so we can see how it's supposed to look on our graphing calculator. Once again, the numerator, make sure that that's in parentheses, so we've got parentheses 9x squared. Oops, why did I do that? There we go, 9x squared minus 9 divided by parentheses, and then it's x squared plus 1. So x squared plus 1. Graph it out. Whoa, that's a weird looking one. Okay, so let's try and make some sense of it by finding the asymptotes, the domain, and all that kind of stuff. So the domain is actually really nice because there's no way that I can turn this into 0. So there's no way to get x squared to be negative, in other words. Unless I use imaginary numbers. So since I can't turn this into 0 with real numbers, that means that I can use all real numbers. There's no domain restrictions from the denominator that I need. And since there's no domain restrictions, that also means that there are no vertical asymptotes, nor are there any holes or removable asymptotes in the graph. So I can put none for both of those. That's pretty easy. Next, let's look for horizontal asymptotes. So we compare the degree. The degree in the top is 2. The degree in the bottom is also 2. When the degrees are the same, we compare the lead coefficients. So the lead coefficient in the top is 9. Lead coefficient in the bottom is 1. So that means that we have a vertical asymptote, horizontal asymptote, I'm sorry, at y equals 9. Okay, so we can just, extend our graph up a little bit. Let me get out a little ruler so that I can draw this line up a little bit better. Okay, let's see here. There we go. Just in case we need to extend it outwards a little bit. Okay, there we go. So here's our graphing axis, and I just did that because I saw that y is equal to 9, so I know that like it fits all in this graph, but I just want to be certain that I can fit it all on here. So we've got 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Our horizontal line goes through there, so horizontal asymptote through y equals 9. Okay, next up, slant asymptotes. Well, if we have a horizontal asymptote, we are not going to have a slant asymptote. Wow, so this is all pretty easy so far. Let's find the X-intercepts. The X-intercepts, they all come from the numerator, and remember that if you have anything that cancels out, then you use that simplified expression, but nothing cancels out in the numerator and denominator, so I just use the two factors in the numerator. I'm going to set them equal to 0. And solve for the x value. So if I have x plus 1 equals 0, that means that x is equal to negative 1, so that's one of my x-intercepts, negative 1, 0. And I can graph that point over here, negative 1, 0. All right, and then if I set this part equal to 0, so x minus 1 equals 0, and solve x equals 1. So 1, 0 is my other x-intercept. So over 1, up 0, there we go. Now let's find the y-intercept. So the y-intercept, if I plug in 0 for x, I get what? So let's see, 0 minus 9, so negative 9. 0 plus 1, 1. Negative 9 over 1 is negative 9. Okay, so I go 9 in the other direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, you know, that kind of makes sense of the rest of the graph. So the graph's going to kind of like go up through the x-intercept and then head towards the horizontal asymptote and kind of like go along the horizontal asymptote in this direction. And then for this one, it's going to do the same thing. Go through the x-intercept, head up towards the horizontal asymptote, and then just kind of follow the line itself, like kind of as a barrier for it. If you want, you can add in a couple other points just for, you know, just for accuracy's sake. So you can go to your table, and I notice that, like, you know, I've got like whatever, something like -3, 7.2, so -3, 7.2, you know, it's like right over there, whatever. Negative, and then +3 probably has 7.2 also, yeah. So, you know, it's about the same coordinate right over there. Just, you know, add those in if you want for a little bit of accuracy, that's fine. And you're done, you know, because you've answered all the questions, you've graphed it out accurately, and have a couple of extra coordinates right there. Okay, that's the second question. Now let's move on to the third one.